Let's find the roots of a complex number. In particular, let's find the third roots of negative root 3 minus I. The first step is to convert this to trigonometric form. And I am going to make an observation. If I take a look at the 12-sector unit circle in the complex plane, that red dot is the complex number negative root 3 over 2 minus 1/2 I. And if I think about that number being multiplied by 2, that is going to give us the complex number on the right side of our equation, isn't it? Yes, it is. So what that tells me is that the complex number negative root 3 minus I is 2 units from the origin, and it's in the direction of 210 degrees. So right along there, and that's going to be our angle. So the distance from the origin is going to be 2, and the angle will be 210 degrees. Quite frequently with these roots of a complex number, we like to stick with degrees because we have to do some division, and quite frequently we get special angles that are a little easier to recognize in degrees. I'm going to write this as 2 CIS. CIS is cosine plus I sine of theta, and the angle is 210 degrees. Now, let's make the note that there are 3 solutions. And I get the 3 solutions by looking up here. We have a third power on z, so that means there's going to be 3 solutions evenly spaced. And so if we space 3 solutions evenly, that means they have to be 120 degrees apart. Now the technique I use for this is to find the first solution using Demoivre's theorem. We know there's going to be 3 solutions, so I'll write z1, z2, z3. z1 I find by taking the third root of both sides. So I'm going to take that complex form over there, or that trigonometric form. I'm going to raise it to the 1/3 power. Demoivre's theorem says, okay, take that 1/3 and put it on the 2 as an exponent. So that is the radius of the circle where the 3 solutions will live, the third root of 2. That will be the circle where all 3 solutions are. And then Demoivre's theorem says take the 1/3 and multiply it by the 210 degrees. So that gives us 70 degrees. So there's the first solution in trigonometric form. The second solution, circle of radius third root 2, CIS, well, they're 120 degrees apart, so I have to add 120 to that. So there's our second solution in trig form. And then our third solution in trigonometric form, we add another 120 here, so we'll have 310 degrees. Now, those are our solutions in trigonometric form. If we wanted to convert those back over to a standard form, we can. Now, in this case, we'd want to use a calculator to do this. So let's go through this process because it is important to be able to round. So first, I'm going to type into my calculator 2 raised to the 1/3 power, and I'm going to take that and round to the nearest hundredth. So that's going to be 1.26. And then we have to do cosine of 70. And so I'm going to multiply that by cosine of 70. And in fact, what I'm going to do on my calculator, I'm not going to use the rounded number, the 1.26. Excuse me. I'm going to use that exact number on my calculator. So instead, let me rewrite this. Where's my eraser? So I'm going to take that 1.26. I'm going to take this 2 to the 1/3 power and multiply it by cosine of 70 degrees. And when I multiply that by cosine of 70 degrees, I will get 0.43. I'm going to round that to the nearest 100th. So 0.43. And then I'm going to do 2 to the 1/3 and multiply it by sine of 70 degrees. And that will be 0.40 I. So there's the first one in standard form. Our second solution in standard form, we'll do the 2 to the 1/3 multiplied by cosine of 190. So I'll type in the same thing, 2 to the 1/3 multiplied by cosine of 190. And rounding to the nearest hundredth, I get minus 1.24. And then I will multiply 2 to the 1/3 times sine of 190 and round to the nearest hundredth, getting minus 2.22i. Third solution, we will use the same process, except we will do cosine of 310 multiplied by the 2 to the 1/3, and that's going to give us 0.81. And then change the sign to cosine to the sine, and we get minus 0.97i. So those will be the three solutions converted back to standard form. And because we don't have special angles here, we've got to do approximations. 2 to the 1/3 is a crazy irrational number, so our only hope in going back to standard form is with approximations, and I chose to go to the nearest hundredth. Fun.